Hello, good afternoon, everyone. Good afternoon. I welcome you all on the official channel of the Gate Academy. So, we were discussing about the most important concepts with super questions. Okay, now audio is clear. I have checked for the audio. So, we were discussing about the concepts of geotechnical engineering, right? So, we have discussed about effective stress, permeability we have discussed, seepage also we have discussed in the last class. So, the agenda for today's class will be to cover two most important chapters of geotechnical engineering, that is consolidation and shear strength of soil. Right. So we will begin with the session. Just let me in the comment box. Let me know in the comment box. Okay. So here is the first question of the day. This is MCQ type question. It means only one answer is going to be correct. So the question reads, Terzaghi's consolidation theory is applicable to one-dimensional consolidation test for. It is asking for the assumption of Terzaghi's consolidation theory. Students, now try to answer. Try to answer this one. Terzaghi's consolidation theory is applicable to one-dimensional consolidation test for. What are the assumptions taken by Terzaghi? We know Terzaghi is known as the father of soil mechanics. Terzaghi has also done his tremendous work in consolidation, has given the consolidation theory. Can you tell me the assumptions? Can you tell me the assumptions for Terzaghi's theory? Okay, let's discuss. So we all remember that Terzaghi theory. Do you remember the spring analogy? You remember spring analogy? There is a cylinder. There is a cylinder which is impervious cylinder having different perforations, different layers having perforations, having different layers with perforations. Right. Now in between this, Terzaghi has taken the springs. He has considered springs. Just tell me which part of this analogy is representing the voids. So, the voids are here represented by perforations. By perforations. By perforations. They are representing voids. What this spring is representing? So, the solids, they are represented by this spring. So solids are representing our spring. Now water is represented. Water is represented by the water filled between the springs. Water. Right. Now when load is applied, what will happen? What will happen at time t is equal to 0? At time t is equal to 0. Who is going to take this load? or which is going to take the stresses induced by this load. So at T is equal to 0, the water is going to take the load, right? Water will carry the load. Water will carry load. If load is carried by water, what will happen? There will be generation of excess pore water pressure there. Due to this generation of excess pore water pressure, Now what is excess pore water pressure? The pressure above the initial value. Initially, suppose if I put a piezometer, suppose at this point, in the middle of this layer, I have put one piezometer here, another piezometer at this point, third piezometer at this point, third piezometer at this point, fourth piezometer at this point, fourth piezometer at, right? So initially the level of water in this piezometer is going to be here. This is the water level. Now when stress is applied, suppose stress applied is, suppose we have applied a stress of sigma. Now if this stress is taken by water, what will be the rise in the level of water? Rise in the level of water, it is going to be sigma upon gamma W, right? It will be sigma into gamma W. So the water level rises by H. It means the excess pore water pressure is equal to gamma W into H, yes or no? The excess pore water pressure, it will be gamma W into H. So this was the arrangement. This spring analogy, it was representing our soil sample, right? Now with increase in time or with movement of time, what will happen? Now this pore water will start expel out from this sample or this arrangement. Now when this water will expel out, what will happen? Now the stresses will be induced in these springs. Now the stresses will be induced on these springs. These stresses are, so these stresses will be our effective stress. These stresses will be our effective stress. Now due to the effective stress, now this spring will get compressed. Thus compression of spring, that is our settlement or consolidation. So with the spring analogy, we have analyzed how the consolidation process is going on a soil sample, right? So what are the assumptions considered by Terzaghi in this? So if we talk about the assumptions, taken by Terzaghi, so assumptions were that soil is homogeneous and isotropic. Yes, Abhishek, for mechanical engineering, first assumption taken by Terzaghi is about soil. Soil is homogeneous and isotropic. Soil is homogeneous and isotropic. Can you tell me what is the meaning of homogeneous? If I am saying soil is homogeneous, what is the meaning of homogeneous? What is the meaning of homogeneous soil? Anyone, can you tell me what is the meaning of homogeneous? if the properties of soil at different points in any one direction are same, at different positions in one direction, if the properties of soil are same, we can say soil is homogeneous. What is the meaning of isotropic? At any point in different direction, if the properties are same, at any point in different direction, it means it is isotropic, right? If I am saying the property, which property of soil is governing our consolidation? So consolidation is governed by which property of soil? That is permeability. So permeability is constant throughout the soil sample. That is our assumption. Second assumption, Terzaghi has considered that soil is fully saturated. It means the settlement or the compressibility due to compaction is not taken into account. Now this theory is applicable to only one-dimensional consolidation. We can see the settlement or the compression of the springs we have considered only in the vertical direction. This is also considered in soil as, we considered soil as semi-infinite medium. It means soil can be deformed only in the vertical direction. All the deformation in the soil, they will be in the vertical direction, right? So applicable to one-dimensional consolidation. Consolidation for small load increment, or you can say the strain values are taken as very small. Why we have considered strain as very small, or why the load increment ratios are small? As we consider that the consolidation is going to be occur only due to the expulsion of pore water, and not due to the strain on the solids, right? So the deformation of solids we are not going to consider in our consolidation. The consolidation is only due to the expulsion of pore water. That's why the small load increment ratios are taken into account. So the correct answer for this question will be option A. Right? So the Terzaghi's consolidation theory is applicable to for small load increment ratios. I hope now this question is clear. The Terzaghi's one-dimensional consolidation theory is clear. Okay, next move to next question. Just move to next question. Try to solve this one. So the question is MCQ type. It means only one of the option will be correct. And the question reads, due to the construction of a new structure, the average vertical pressure at the center of a 2.5 meter thick clay layer increases from 100 kilopascal to 200 kilopascal. A laboratory consolidation test was performed on 20 mm thick undisturbed sample of the clay under applied stresses of 100 kilopascal and 200 kilopascal. The void ratio of the sample was found to be 0.9 and 0.786 respectively. Compute the primary consolidation settlement. एक नए स्ट्रक्चर के बनाने से जो स्ट्रेसेस डेवलप हुए हैं एट 2.5 मीटर बिलो, at 2.5 meter thick layer of clay, they increases from 100 kilopascal to 200 kilopascal. स्ट्रक्चर के कंस्ट्रक्शन से जो एक 2.5 मीटर थिक लेयर है उसके सेंटर पे जो स्ट्रेसेस इंक्रीमेंट हुए हैं, इट मींस कंप्रेसिबल लेयर के सेंटर पे आपको स्ट्रेस में चेंज बता रहा है. तो एट द सेंटर ऑफ कंप्रेसिबल लेयर, दैट कंप्रेसिबल लेयर इज क्ले, so stresses changes from 100 kilopascal to 200 kilopascal. Now what you have done to study the consolidation, आपने क्या किया, आप फील्ड से एक सैंपल लेके आए, उस पर कंसोलिडेशन टेस्ट किया, सेम स्ट्रेसेस अप्लाई किए, आपने स्ट्रेस चेंज किया वैल्यू 100 kilopascal से 200 kilopascal पे, आपने वॉइड रेशियो मेजर किया जब स्ट्रेसेस थे 100 kilopascal, जब स्ट्रेसेस 100 kilopascal थे आपके पास जो वॉइड रेशियो था दैट इज 0.9. आफ्टर एप्लीकेशन ऑफ 200 kilopascal नाउ वॉइड रेशियो विल डिक्रीज. अगर सॉइल में स्ट्रेसेस अप्लाई कर रहे हो तो क्या होगा, वॉइड रेशियो विल डिक्रीज. नाउ द वॉइड रेशियो बिकम 0.786. आपको बताना है कि जो स्ट्रक्चर का सेटलमेंट है वो कितना हुआ है. नाउ यू हैव टू आंसर व्हाट इज द probable primary consolidation settlement of the structure. Try this one. Try this one. Try करो. Try to answer this. Try to answer this. I think 1 minute will be sufficient to answer this type of question. Just see the data and try to answer. Try to answer. Okay, let's discuss. Let's discuss. कभी भी प्राइमरी सेटलमेंट कैलकुलेट करने का क्वेश्चन आए, whenever you find any question on primary consolidation settlement, remember there are only 3 ways to calculate. First is, if you know the change in void ratio, so delta H upon H, it is delta E upon 1 plus E naught. अगर आपको इनिशियल वॉइड रेशियो पता है, आपको चेंज इन वॉइड रेशियो पता है, अगर आपको पता है व्हाट इज द थिकनेस ऑफ कंप्रेसिबल लेयर, so you can find the primary consolidation settlement. Here delta S is our primary consolidation settlement. What is H? H is the thickness of compressible layer. Thickness of compressible layer. What is delta E value? Delta E is our change in void ratio. Delta E is our change in void ratio. अब ये void ratio में change क्यों आएगा? This change in void ratio is due to application of stresses. Now this application of stresses, it can be due to natural causes or due to the man-made causes. If suppose you have constructed one structure over the soil, there will be increment in stress. If suppose there is a snowfall, so due to that snow layer, there will be increment of stresses. So increment of stress, it can be either due to natural causes or man-made causes. What is E naught? E naught is our initial void ratio. E naught is our initial void ratio. Second, we know delta H is equal to H naught mv delta sigma bar. H naught mv delta sigma bar. What is mv here? mv is coefficient of volume compressibility. Coefficient of volume compressibility. Volume compressibility. mv given by Av upon 1 plus E naught. Given by Av upon 1 plus E naught. Now what is this Av? Av is our coefficient of compressibility. Coefficient of compressibility. Now I'm assuming that you know what is coefficient of compressibility. It is the slope of curve between the effective stress and void ratio. With change in effective stress, what is the change in void ratio? The slope of that curve. That is our coefficient of compressibility. It represents the magnitude of consolidation. What will be the magnitude of consolidation? That is represented by our Av. Right. What is delta sigma bar? Change in effective stress. Change in effective stress at the center of compressible layer. At the center of compressible layer. This is our second formula. Third formula can be, third formula for calculation of primary consolidation, that is delta H is equal to H naught Cc upon 1 plus E naught log base 10. Sigma naught bar plus delta sigma bar upon sigma naught bar. Now what is this Cc? This is coefficient of compression. Coefficient of compression. Av was our coefficient of compressibility. This is our coefficient of compression, or you can say compression index. It is the slope of void ratio curve between the void ratio and log of effective stress. Log of effective stress and void ratio. The slope of that, it is given by coefficient of compression, that is Cc. This value also represents the magnitude of compression. What will be the magnitude of compressibility? That is represented. So we have three formulas. Now just see what are the data given. What are the data given? So data given is delta sigma bar is also given to us. Delta sigma bar is given for 2.5 meter thick layer. Right. Also delta sigma bar is given for 20 mm sample which we have tested in the lab. The change in void ratio is given from 0.9 to 0.786. From 0.9 to 0.786. Now as the increment in stresses are same, it means your MV value is going to remain same. Your MV value will be same. Right. So first method, how we can calculate? H naught is given to us. H naught is our 2.5 meter. Sigma naught bar, it is given as 100 kilopascal. Delta sigma bar is given to us 200 kilopascal. Delta sigma bar is given to us, that is 200 kilopascal. Now this is for the soil in the field. Also, the soil sample which we have taken for the lab test is also given. What is H naught here? 2 mm. What is sigma naught bar? 100 kilopascal. It is sigma 1 bar. Let's take it as sigma 1 bar. Sigma 1 bar is 200 kilopascal. Now, initial void ratio is given. When stress was 100, void ratio is given as 0.9. Final void ratio, even, it is also given as 0.786. 0.786. Can we calculate the value of MV? MV is equal to AV upon 1 plus E naught. AV is the slope of change in void ratio, or you can say it is the change in void ratio with change in effective stress. This type of curve we generally got. Okay, so here it is void ratio, here it is our effective stress. So initially the effective stress was 100, then void ratio was 0.9. Now void ratio changes to this value, 200. No, effective stress changes to 200, void ratio becomes 0.786. So AV is the slope of this curve. It means change in void ratio. Slope will be dy by dx, change in void ratio with change in effective stress, divided by 1 plus E naught. Divided by 1 plus E naught. So, just put the values. Delta E, 0.9 minus 0.786 by 200 minus 100 divided by 1 plus E naught, 1 plus 0.9. Can you give me the value of MV? Can you give me the value of MV? What is the value of MV? What is the value of MV? So MV value we are getting as 0.006. What will be the unit? Meter square. Stress is in kilopascal, kilonewton. Right. Now MV value is same. I can calculate delta H here. I need the settlement delta H. It is equal to H naught MV delta sigma bar. What is the value of H naught? 2.5. What is the value of MV? 0.006. 0006 into delta sigma bar is 200 minus 100, that is 100. That is 100. So 0.15 meter, or you can say we have to answer in mm. It is 150 mm. It is 150 mm. You can also calculate directly without calculating MV. If you use, as the stresses values are same, the stress change in your original soil and in the soil sample which you have taken to the lab. As those values are same, so you can directly use H naught upon H. It is equal to delta E upon 1 plus E naught. You can also do in this way also. So H naught is our 2.5, delta E 0.9 minus 0.786 upon 1 plus 0.9. Still you will get same value. That is 150 mm. Still you will get same value as 150 mm. Okay. Is there any doubt? Is there any doubt with this question? I hope this question is now clear to you. Let me know if you have any doubt. Let me know in the comment box if any student is having any doubt. Okay. So we will move to our next question. This is our next question. Our next question from the settlement. Answer this one. The consolidation settlement of a new structure founded on a 6-meter thick layer estimated as 77 mm. The structure was found to have settled by 21 mm in 8 months after the completion of construction. If the clay layer is underlain by rock and overlain by a layer of coarse sand, the coefficient of consolidation of the clay layer will be. You have to answer the coefficient of consolidation of clay layer. What will be the coefficient of consolidation of clay layer? Answer this one. Try to solve. Just try to solve. See the data. Make a flow chart to solve the question. If that flow chart is complete, then go for the question. Then only go for the question. It's not like this that you have noted the data, then try to solve that, and after a point you come to the conclusion that no, now I don't know the concept to solve this question. So that will be a time waste, right? तो आपको करना क्या है, क्वेश्चन को पढ़ो, डेटास देखो क्या दिए हुए हैं, उससे आपको एक फ्लो चार्ट बनाना होगा कि आप आंसर तक कैसे पहुंचोगे. अगर आपको वो फ्लो चार्ट मिलता है, then attempt that question. Otherwise, for the first time, mark that for the review, and in the second go try to solve that. अगर आपको पहली बारी में लगता है कि ये क्वेश्चन का कॉन्सेप्ट मुझे नहीं पता है, या फिर इस क्वेश्चन को जो सॉल्व करने का फ्लो चार्ट है वो आपके माइंड में नहीं बन रहा है, तो ऐसे क्वेश्चन को रिव्यू के लिए डालो, और जब एक बार पेपर सॉल्व कर दो उसके बाद ट्राई करो इस टाइप के क्वेश्चंस को. ठीक है, नाउ ट्राई दिस वन. Okay, D 0.26. Harsha got 0.26. Let's see. The consolidation settlement of a new structure founded on a 6-meter thick layer estimated as 77 mm. It means the compressible layer having a thickness of 6 meters. What is the estimated settlement? It is 77 mm. So this is the complete settlement estimated, primary consolidation settlement. Now at any particular time, at t is equal to 8 months, at t is equal to 8 months, your settlement value is 21 mm. Your settlement value is 21 mm. Can you tell me what will be the degree of consolidation? Degree of consolidation represent at any particular time. How much percentage of consolidation has taken place? Can you tell me what will be the degree of consolidation? Can you tell me what will be the degree of consolidation? So degree of consolidation, it is delta H upon H, delta small h into delta capital H into 100. Okay, 27.27%. 27.27%. It is less than 50%. Value is less than 50%. It means if we calculate the time factor, it will be equal to pi by 4 into u percentage. Pi by 4 into u percentage. We also know what is the value of TV. It is CV into T upon D square, where CV is our coefficient of consolidation, T is the time taken, D is the drainage length. Now it is given that, suppose this is the soil sample, this is the soil, now here it is clay, this is our sand, and here it is a rock. It means this layer will be impervious layer and this layer is going to be pervious layer. So the drainage path is the maximum distance taken by a water molecule to expel out from the layer. So this will be the layer, this will be the value of D, that is 6 meters, that is 6 meters. Okay, so just put the values. Pi by 4 into 0.2727, it will be square, u square is equal to CV. CV value is needed to be calculated, T, that is 8 months divided by 6 square. Divided by 6 square. Can you give me the value of CV? Can you give me the value of CV? What is the value of CV you are getting from here? 0.263. 0.263. What will be the unit? Meter square per month, as the time is in months. Meter square per month. So the correct answer for our question will be option D. Yes, Harsha has given the correct answer, 0.26. Okay, next question. Next question. A clay sample, originally 28 mm thick, at a void ratio of 1.02, was subjected to compressive load. After the clay sample was completely consolidated, its thickness was measured to be 23 mm. The final void ratio will be. What will be the final void ratio? What will be the value of final void ratio? Try to answer this one. Again, the hint is there is a settlement from 28 mm to 23 mm. So whenever there is a case of settlement, we have discussed, we have three formulas. So try to see now, according to which formula the data is given to us. According to which formula the data is given to us. Can you tell me what is the value of settlement here? Before starting the question, can you tell me what will be the value of settlement? How much the soil layer has settled? How much the soil layer has settled? By what amount this clay sample has settled? Its original thickness was 28 mm. Now after complete consolidation, its thickness is measured to be 23 mm. Can you tell me the value of settlement? Can you tell me the value of settlement? So the value of settlement value is, what was initial thickness? 28 mm. Now finally after settlement the thickness become 23 mm. It means this is the value by which our soil layer gets settled. That is 5 mm. That is 5 mm. Now this 5 mm settlement is of which layer? Having a thickness of 28 mm. Having a thickness of 28 mm. Now when the thickness was 28 mm, void ratio is given. It means initial void ratio is given to us 1.02. 1.02. Now settlement values are given, void ratio is given. We can use delta H upon H. It is equal to delta E upon 1 plus E naught. What is delta E? Delta E is change in void ratio, that is initial void ratio minus final void ratio. So initial void ratio minus final void ratio divided by 1 plus E naught. Delta H value is 5 mm. Total thickness 28 mm. E naught value is 1.02 minus E final value we need to calculate upon 1 plus E naught. Initial void ratio 1.02. Can you tell me what is the value of final void ratio? Can you tell me the final void ratio? What is the final void ratio you are getting? What is the final void ratio you are getting? What is the final void ratio you are getting? So the final void ratio it is 0.66. Final void ratio is 0.66. So our answer will be 0.66. 0.66. If you like the session, don't forget to hit like. If you are enjoying this session, don't forget to like the session. Okay. Okay, now this question is clear. The question is clear. Next. Just move to next question. Just move to next question. Now it is given, if the time required for 50% consolidation of a remolded soil sample of clay with single drainage is T, then what is the time required for 80% consolidation of the same sample of clay? Same sample of clay. Just try to answer this one. Just try to answer this one. Just try to answer. If the soil sample is same, which value is going to be constant? Now this is your hint. When it is given that the same sample of clay, it means you can compare both the condition on those values which are constant. कभी भी इस टाइप का क्वेश्चन आए तो कौन सी वैल्यूज कांस्टेंट है उस पर फोकस करो, क्योंकि वही एक वैल्यू जो दोनों कंडीशंस को क्या कर सकती है, कंपेयर कर सकती है. So you have two condition. In one condition there is 50% consolidation, in second condition there is 80% consolidation. Now you have to compare these two values. Now you have to compare these two conditions. Which parameter is going to be constant? Which parameter for a soil going to be constant? What about coefficient of consolidation? It will be constant or it will vary? The coefficient of consolidation, it is going to be same or it is going to vary? So coefficient of consolidation will be same, right? That is our hint. That is our hint. So let's take first case. For 50% consolidation, when degree of consolidation is 50%, the time is t. Time is given as t. We can calculate time factor, as time factor is the parameter which give you the relation between coefficient of consolidation and time. So TV is CV into T by D square. For U is equal to 50%. What will be the value of TV? Pi by 4 into U square. It is going to be equal to CV into T by D square. CV into T by D square. Now just put the values. Pi by 4 into U is 50%, 0.5. CV by D square. Let's take T here. Let's take T here. Just make it quick. Equation 1. Now let's see the second case. For consolidation is equal to 90%, or it is given 80%. 80%. It is greater than 60. Greater than 60. So TV will be equal to 1.781 minus 0.9332 log base 10. 100 minus U in percentage. 100 minus U in percentage. TV will be equal to CV into, suppose the time taken for 80% consolidation is T1 by D square, as there is no change in the drainage length. TV is going to be constant. It will be equal to, just put the value, 0.566 0.566, right? Now CV upon D square, it is 0.566 by T1. Now can we compare equation 1 and 2? Just compare equation 1 and 2. So it is equal to pi by 4 into 0.5 square upon T. It will be equal to 0.566 upon T1. 0.566 upon T1. Just calculate the value of T1. That is our answer. Try to calculate the value of T1 in terms of T. What will be the value of T1 in terms of T? 0.566 divided by pi by 4 into 0.5 square into T. This is 2.88 T. 2.88 T. So the time taken for 80% consolidation, it will be equal to 2.9 times of T, or you can say 2.88 times of T. So the answer for this question will be option A. Option A. So what is the trick here? Whenever two situations are given to you, just try to find out that quantity on that basis, or on which basis you can compare those two situations, right? Okay, just move to next question. Here is our next question. Try to solve this one. The question reads, the time required for a clay to undergo 80% consolidation is 15 years. So for 80% of consolidation, the time taken is 15 years. If the thickness of clay layer was twice as thick, 3 times more permeable, and 2 times more compressible, then the time required for same consolidation will be. Now again, there are two situations. In one case, the soil is having, suppose, thickness H. So in second case the thickness is now twice. Suppose in first case the permeability is K. Second time permeability increases by 3 times, and compressibility has also increased by 2 times. So we again have two type of situations. Now compare on the basis of the constant quantity. Which of the following quantity is going to be constant between these two situations? Okay. We know this time the degree of consolidation is same. This time the degree of consolidation is same. It means TV value is going to be constant. TV value will be our constant. Our TV value is going to be constant. Right. What is TV? CV into T by D square. Now soil sample is same. It means CV values will be also be constant. CV value also going to remain constant. What is the relation between T and D? We need to find the relation of T with respect to the thickness of layer, with respect to the permeability, and with respect to the compressibility. So T is directly proportional to D square. T is directly proportional to D square from this formula. What will be the relation of T with K? What is the relation of T with K? How T and permeability are related. If the permeability of soil is more, what will be the time taken for the consolidation? If permeability of soil is more, the time taken for a particular consolidation will be less or more? It will be less or more. So if permeability is more, the time taken will be less. Or we can understand this also from this relation. We know that T is inversely proportional to CV. TV is inversely proportional to CV. What is the formula for CV? We know CV is equal to K upon mv into gamma w. K upon mv into gamma w. It means CV is directly proportional to K. CV is inversely proportional to T. It means K is also going to be inversely proportional to T. Now, just compare the compressibility. Now, compressibility factor, it is given by AV. AV we know it is directly proportional to MV, and MV, from here we can compare MV. It is inversely proportional to CV, which is inversely proportional to CV. So it means time, it is directly proportional to AV. Time is also directly proportional to AV. So now, can I say that for any two conditions, T is equal to constant d square. Let's take constant as C. So T is equal to any constant C d square into AV upon K. Or I can say, if I compare two soils, so it will be T1 upon T2. T1 upon T2. It will be equal to D1 square by D2 square into K2 upon K1 into AV1 upon AV2. This thing I can write. Now, suppose for first layer, the thickness is D. For first layer, thickness is, time is given. For 80% consolidation in first case, it was 15 years. So T1 is our 15 years. T2 we need to calculate. What is D1 value? Suppose D1 value is D. So D2 is 2 times of D. 2 times of D. It is given that the thickness of clay layer was twice as thick. Permeability is 3 times. So suppose K1 is equal to K. K2 will be 3 times. Suppose AV1 is equal to AV. Its compressibility is also 2 times more compressible. Okay. So if you calculate T2, it will be 15 into 4 divided by 3. 2 2s are 4. Okay, square. D square. This value will be 4. 4 into 2. 4 into 2. So it will be equal to 40 years. 40 years. Now for same consolidation, the time taken will be equal to 40 years. Right? I hope now this concept is also clear to you. So whenever there is comparison between two conditions, just look for that quantity which is constant. Just look for that quantity that is constant, because on that basis only you can compare those two conditions. So the correct answer for this question is option D. Correct answer is option D. Now let's move to next question. Next question. Now this is from the shear strength of soil. Our next question is from shear strength of soil. Try to answer this one. Try to answer this one. In a consolidated drained triaxial shear test on a normally consolidated clay, the sample fails at a diametric stress of 100 kN per meter square when subjected to a confining stress of 100 kN per meter square. The angle of internal friction is. Now it is asking for the value of angle of internal friction. Just try to answer. Just try to answer. Now just to give you a hint, let me draw the Mohr circle for this condition. I will just draw a Mohr circle for this condition. Okay, you try to solve this one. You try to solve. So it is given that the sample fails at a diametric stress of 100 kN per meter square and subjected to a confining stress of 100 kN per meter square. Can you tell me what will be the value of minor principal stress? Can you tell me the value of minor principal stress? Can you tell me the value of minor principal stress in this case? What will be the value of sigma 3? What will be the value of sigma 3? Can you tell me the value of sigma 3? Can you tell me the value of sigma 3? So, confining pressure is given. It means sigma c is given to you. Nothing but equal to sigma 3, 100 kN per meter square. Diametric stress is given, 100 kN per meter square. What will be major principal stress? Sigma 1. It will be diametric stress plus your confining pressure. Diametric stress plus confining pressure equal to 100 plus 100. That is 200. Now if I represent this value in your Mohr circle, this is our sigma 3, that is 100. This is our sigma 1, that is 200. So here it is sigma, here is shear stress tau. Here it is shear stress tau. Now it is given that consolidated drain test. Consolidated drain test. CD test. CD test. What will be the value of C? What will be the value of C? So for CD test, value of C is going to be 0. C is going to be 0. phi value we need to calculate. So in this mover circle, if I represent C is equal to 0, it means the failure plane will pass through the origin. The failure plane will pass through the origin like this. So here C is 0. What this angle represents? This angle is our phi. This angle is our phi. Right? Now suppose this is the center of the circle. Suppose this is the center of the circle. I am drawing a perpendicular from here to the center. This is perpendicular. Can you tell me what will be the radius of this Mohr circle? Can you tell me the radius of this Mohr circle? Can you tell me the radius of this Mohr circle? It will be equal to shear stress value sigma 1 minus sigma 3 by 2. What will be the distance of center from the origin? What will be the distance of center from the origin? It will be sigma 1 plus sigma 3 by 2. Sigma 1 plus sigma 3 by 2. Now I know what is the value of sigma 1. I know what is the value of sigma 3. Can we find the value of phi from here? Which angle should I use? So can I say sin phi? Sin phi. Sin theta is perpendicular upon hypotenuse. This is our perpendicular. Sigma 1 minus sigma 3 by 2. What is our hypotenuse value? Sigma 1 plus sigma 3 by 2. It is equal to sigma 1 minus sigma 3 upon sigma 1 plus sigma 3 upon sigma 1 plus sigma 3. Just put the values. Sigma 1 200, sigma 3 is 100, sigma 3 is 100, 200 plus 100. So it is equal to 1 by 3. So phi value, if we calculate from here, it will be sin inverse 1 by 3. It will be equal to sin inverse 1 by 3. Okay. So I hope now this concept is clear. How to use Mohr circle for this type of question. Now it will be clear to you. Just let me know in the comment box if this question is clear to you now. If this concept is clear. So the correct answer is option A. Our option A is correct. Our option A is correct. So phi is equal to sin inverse 1 by 3. Phi is equal to sin inverse 1 by 3. Right. Okay, let's move to next question. Let's move to next question. At a depth of 5.5 meter below the ground surface at a site, a Vane shear test gave a torque value of 6145 Newton centimeter. At failure, the vane was 12 centimeter high and 6 centimeter in diameter. The shear strength of soil. Now remember the unit. The shear strength of soil is needed to be calculated in kilonewton per meter square. Will be. You have to assume that shear has occurred at both top and bottom of the vane. Shear has occurred at top and bottom of the vane. Now this is the question from Vane shear test. Vane shear test. Let me know in the comment box if Vane shear test is a field test or a lab test? Vane shear test is a field test or lab test? Can anyone tell me that the Vane shear test, it is a field test or it is a lab test? So Vane shear test. Our Vane shear test is, it can be conducted either at the field or at lab. Okay, so Vane shear test, it is in situ test as well as your lab test. The only difference will be in the size of vane. The size of vane which you are going to use in field. The size of vane you are going to use in field, it will be greater than that you are using in lab, right? So our Vane shear test, it is both lab test and field test. I hope now this doubt is clear. Now, can you tell me any other method for the calculation of shear strength of soil? Any other method for the calculation of shear strength of soil? Which test for the calculation of shear strength of soil is most accurate? Which test is most accurate? Can you tell me any other method for the calculation of shear strength of soil? So for the calculation of shear strength of soil, we have our triaxial test, right? So the most accepted test is, that is our triaxial test. We also have direct shear test, generally used for sandy soil. Okay, now try to solve this one. Direct formula based question. Direct formula based question. Now if we talk about triaxial test. Okay, Vane shear test. This is from the Vane shear test. So there will be a vane inserted in the soil sample. A vane inserted in the soil sample. Right. A vane inserted in the soil sample. Now you are going to rotate this. You are going to apply a torque, a rotational movement on this vane. So at any value of torque T, suppose at any torque value T, this soil sample fails. This soil sample fails. You have noted that T value. You know what is the length or what is the height of these vanes? What is the diameter of vane? Suppose this is another vane. This is the diameter of vane. These are known to you. So the shear strength of soil, it is given that T upon pi d square h by 2 plus d by 6 plus d by 6. It is when shearing is at both top and bottom. Is at both top and bottom. Right. Now, if shearing is only at the bottom, this relation will be T upon pi d square h by 2 plus d by 12. This is the only difference. This is the only difference. So when shearing is at bottom only, Shearing means when you rotated this, if this top layer is also shearing the soil, this bottom layer is also shearing the soil. That is our two-way shearing. If this part is above the soil layer, only bottom layer will shear this soil. That is our one-way shearing. Okay. So here it is given that shear had occurred both at top and bottom of the vein. It means we are going to use this one. So let's take the data. Let's take for the data. S is equal to T value is given 6145. What is the unit? Newton centimeter. 10 to the power minus 3 become kilonewton. 10 to the power minus 2 become meter. Divided by pi d square. What is the value of d? What is the value of d? 6 centimeter. 6 centimeter. 0.06 upon h by 2 plus d by 6. What is the value of h? 12 centimeter is the height. So 0.12 plus d by 6, 0.06 by 6 by 6. Now it will be in kilonewton per meter square. Can you give me the value in kilonewton per meter square? Try to calculate this and give me the value in kilonewton per meter square. The value required is in kilonewton per meter square. So after solving this, we are getting as 77.62. 77.62 kilonewton per meter square. 77.62 kilonewton per meter square. For the PDF of any session, you can refer to the official channel of the GATE Academy in Telegram. The link will be available in the description. So the correct answer for this question is 77.62. Now just move to next question. Move to next question. If Cu is the undrained cohesion of soil and Qu is the unconfined compressive strength of the soil, then the radius of Mohr circle for unconfined compression test result is, then the value of or the radius of Mohr circle for unconfined compression test result will be, unconfined compression test result will be. Now give me the answer. Give me the answer. Before that, just see one trick. Whenever if C value is not given, if C value is not given in any question, if only one data is given for sigma 1 and sigma 3, trick for shear strength. Trick for shear strength of soil. In this unit you will need this trick. One major formula for this unit is that at plastic stage, when sigma 1 at failure, it is equal to sigma 3 at failure. 10 square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2 2c 10 45 plus 5 by 2. So whenever there will be sigma 1 and sigma 3 in the question, अगर आपको सिग्मा 1 और सिग्मा 3 की वैल्यू दी हुई है या फिर सिग्मा 1 और सिग्मा 3 की वैल्यूज पूछ रहा है, तो हो ना हो ये इक्वेशन यूज होने वाला है वहां पर. दिस इक्वेशन इज गोइंग टू बी यूज देयर. नाउ इफ सपोज to solve this question we have parameter as sigma 1 sigma 3 phi and c, four parameters. Suppose one soil condition is given. If one soil condition is given to you, it means you will have one phi value and one c value. So if phi value and c value is known to you, now there will be two unknowns, sigma 1 at failure and sigma 3 at failure. Now with one equation we can only find one parameter. So for that, it means another condition should be given, another value of c and phi should be given there. Now suppose second case, suppose sigma 1 at failure and sigma 3 at failure is given, and you need to calculate phi and c value. Now you will also need two equations to find these two unknowns, phi and c. But suppose in exam you have been given only one equation in terms of sigma 1 and sigma 3, which will be general in your case. आपकी केस में ज़्यादातर क्वेश्चन ऐसा ही पूछा जाएगा. So in that case, just remember, if your triaxial test, it is, we have unconsolidated undrained test, UU test, we have consolidated drain test, and we have CU test. So here you will find C value, here it is C value. So for these two tests, C is going to be 0. Your cohesion value is going to be 0. For UU test, your phi value is going to be 0. So if there is only one equation in terms of sigma 1 and sigma 3, and you need to find C and phi value. So based on the type of triaxial test, you can assume either C as 0 or either phi as 0. If it is UU test, your phi will be 0. If it is consolidated drain test or consolidated undrained test, C will be equal to 0, right? Okay, now let's back to the question. It is our undrained test. It means phi value is 0. Let's try to draw the Mohr circle for this question. So let me take one shape. Okay. Okay. This is going to be our result for unconfined compression test. Unconfined compression test is unconfined compression test. It means sigma 3 value will be 0. Sigma 3 value will be 0. So I have represented sigma 3 as 0. I have represented sigma 3 as 0. This will be sigma 1. This will be sigma 1. What about the failure envelope? Failure envelope, there will be C value, but phi value will be 0. So phi value is 0. This is the case. So this will be our failure envelope. This will be our failure envelope. This is the value of C. This is the value of C. Cohesion value. Is it the radius of Mohr circle? Is it equal to the radius of Mohr circle? So the radius of Mohr circle for unconfined compression test, it will be equal to Cu. It will be equal to Cu. Right, this is the value of Cu. I hope you got the solution for this question. Okay, this is all about the session. Do not forget to like the session and share this with your friends. We will meet tomorrow at the same time with more quality questions. Okay, everyone. Have a great day. Thank you.